And again, I'd like to welcome you to our AWS Webcast today, Amazon Web Services for Development and Test. And now I will hand it over to Paul Duffy, our presenter. Paul, you have the floor.
Good afternoon, and thank you to everybody for joining this webcast. My name is Paul Duffy, and I'll be presenting this webinar today. And what we're going to be talking about is how Amazon Web Services can be useful for development and test scenarios. In terms of the agenda that we're going to cover, first of all, we're going to talk about some of the challenges that we hear from our customers and look at how we believe AWS can help address some of those challenges. Following that, we're going to give an overview of AWS because this webinar is primarily aimed at our potential customers and users who are not making significant use of AWS at the moment. So we're going to take an overview of some of the key AWS services that might be used in addressing the challenges that we've talked about. We'll then provide a short demo of some of those services in action and then look at some of the next steps for moving forward with AWS. So first of all, some of the challenges that we hear from our customers in the dev and test environment that they're used to experiencing in their on-premises environments. And some of these, the first one, is really a pretty simple one. And that is, it's difficult to easily get compute resources. Obtaining servers can often be measured, depending on the process in your organization, in weeks or even months. And certainly traditionally, getting on-premise physical resource is not something that tends to be measured in minutes. Particularly relevant in development and test environments, managing multiple environments can be tough. Traditionally, this is physical hardware that has to be procured, has to be managed, and then also has to be kept for longer than customers necessarily want. We believe these two challenges come together to make experimentation slower for customers and make it more difficult for you to innovate on behalf of your businesses than you'd necessarily like it to be. So how do we think that the AWS Cloud might be useful for you? So to address the first challenge, and again this is a pretty simple thing, is to make it very easy to obtain compute resources in minutes. So instead of measuring this in weeks or months, it's very easy to get compute resource quickly, and then also when you're finished with it, to avoid having to have long-term commitments. And we're going to go through these three different areas in a moment. We also believe being able to manage multiple environments is much easier in the AWS environment. If you need to spin up an extra test environment for a particular project, you can do that very, very quickly. You can dispose of that very, very quickly when you're done with it. And we believe that these two things can combine to make it much easier for you to address the challenge we talked about on the previous slide, to make it easier to experiment on behalf of your businesses. So from the point of view of obtaining servers, obtaining compute resources, in the past in the on-premises environment, and I'm sure everybody is aware of this, whether or not you're directly responsible for the kind of the catalog or the exact server that's being purchased, some work has to be done to do the right kind of research to choose the hardware that's required. And it might be an internal service catalog, it might be more research that you have to do. Then to go through the actual procurement process, it might involve budgetary approval, but it's typically going to involve a capital expenditure that's potentially going to involve hardware that's going to stick around for a number of years. Go through the process of opening a purchase order, eventually getting the hardware, having it racked and stacked in a data center, and finally being able to get access to that hardware to do the work that you want. In the AWS environment, you could add a new development environment, you could add a new production environment, you could add another kind of test environment. You could do that in the location that's closest to where you work. You could do it in another country like Japan, and we'll talk about the various bits of infrastructure we have across the world shortly. You could add 1,000 servers, remove 1,000 servers, and you could do all of these things in minutes, only paying for what you use. If you use your servers for the duration of the webinar that we're having now, when we finish with that, we can turn them off. There's no long-term commitment. If you need them for a few hours, that's all that you'll end up paying for. If you need them for longer, the same kind of thing. And it provides a level of flexibility that really wasn't there in the past. From the point of view of managing different environments, let's take creating test environments, for example. In the on-premises environment, this wasn't necessarily very easy. If it was going to be a true mirror of a production environment, then you really had to duplicate it. And that potentially meant duplicating costs, duplicating infrastructure, duplicating the effort to procure and deploy and manage that infrastructure. And then the other thing, meaning it's difficult to dispose of. That might not be a challenge for a kind of long-lived test environment, but if you needed something extra for one project, very difficult to get rid of that hardware where there's been a capital expenditure. It's likely to have to stick around with the associated costs. In the AWS environment, it's very easy to create multiple test environments in a very, very simple manner. With a script, with a few mouse clicks in a console, and we'll see a demonstration of that later. You could spin up a new test environment for a particular project. You can create or delete that in minutes without the heavy lifting associated with the on-premises environment. And then you also only need these environments to be around for the time that you need them. So there's a side project that needs to be done with an offshore team in a different environment. You can create an environment for them to use for the week or the month or the year that they're going to use it for. When they're finished, you simply turn it off and you've only paid for what you use. We believe these things can come together to make it easier for you to experiment quickly on behalf of your businesses. In the on-premises environment, if you were going to try and test out a hypothesis or try and do something quickly for the business, you aren't necessarily able to experiment as frequently as you'd like. And we're told by customers that they don't experiment as frequently as they like. A failure of a simple hypothesis can be expensive because you've had to procure hardware, you've had to make a commitment to do that. And we believe that leads to less innovation for your businesses. With AWS, we think it's easy to experiment often. The cost of experimentation is extremely low. And if your hypothesis, if your experiment doesn't work out, it's easy for you to fail quickly at a very low cost without having to make that commitment, making it easier to make the decision in the first place. We think that's something that can lead to more innovation for the businesses that you're in. AWS also gives you access to some new scenarios, which are traditionally things that just haven't been possible to do in an on-premises environment. You have the ability to make different kinds of choices. So this little table on the left is really just to kind of show at a high level that we can now look at running perhaps one server, one instance for 2,000 hours. We could run 2,000 instances for 1 hour. And it's not so much we're talking about the absolute price here, but saying that the price for doing all of these combinations is the same. So if you had a test that you needed to do that required a large number of servers to load test your application or something like that, you could run those 2,000 instances for 1 hour to do a very highly scaled test in a short period of time, or you could do it with one instance over a much longer period of time. If you had a computationally complex build process, for example, you could speed that up and shorten the time frame just by deciding the number of instances you want to run, and instead of being stuck with the rigid hardware that you typically would have in a data center, here you can make these decisions. And if you decide that you wanted to run 2,000 instances for an hour, or even a higher number of instances for a shorter period of time, you run them to complete the work, and then when you're finished, you turn them off. You pay only for what you use, and there's no upfront commitment, so the risk is very low. And if you look at how you were going to spend even $100 in the AWS environment, you have lots of different combinations of resource that you can use. And with all of this, you're not committed to those resources sticking around for any longer than you need them for your project. And the words of our customers are the most powerful, so we have a couple of case studies that we want to include here. And the first of those is Shell, a brand that I'm sure most people on the call are aware of. And Shell use AWS to develop software faster and more cheaply. Here, they can use AWS with their core development team, for example, and then as they need to increase the amount of resource they need for extra development resources in potentially remote locations, they can easily add resources, fuel the duration of that project, which might be weeks or might be months, and then when they're done with that, they can just reduce that resource footprint so they're not left with all this infrastructure that they were only using for a single project. Or even worse, they're not left in a situation where they'd have to make a decision to slow a project down because it's not worth procuring physical hardware for such a short period of time. Another customer we have here, Orange Digital, who use AWS and Puppet for application development. And in their words, moving to AWS has reduced the time to market for new products. It makes them much easier for them to develop software, to decide what they want to do, to experiment. They can make that production environment for their developers. They can replicate that extremely easily, giving them more ability to experiment and more ability for them to innovate on behalf of their customers. Voyager's SNCF, they use AWS for performance testing. This is very significant for them. It went from 8 months for delivering the platform for them to do that testing. Now they've reduced that to a much shorter period of time with AWS. So 3 high-level scenarios, and there's more information about those case studies on our website if you'd like to read more, but 3 real-life customers who really find AWS is making a difference there. So this first part of the presentation was really going into detail about some of the challenges that we perceive customers have, that we hear from our customers, and some of the ways that we believe AWS can help out there. The next part of the presentation is going to be going into some more information on what is AWS, because we appreciate many of you may not be current users. So we're going to spend some time going through some AWS concepts at a high level, and then focusing on some particular services that are relevant for first steps in development and test environments. So from a resource point of view, AWS has infrastructure located in various different places across the globe. 9 regions, and these are geographically isolated places where you choose where to put your data and you choose where you want to put your compute resources and so on. And they're located in various parts of the world. It's very, very simple from you using the same set of tools, using the same set of APIs. If you wanted to deploy some infrastructure in the EU West region in Ireland, and you wanted to take the same infrastructure and deploy that on the west coast of the US or in Sydney, Australia, it's the same consistent tool set. Very, very easy. If you had a development project that was going on in Australia, you could take the development or the test environment that you had provisioned in Europe, and using the same script, you could spin that up very quickly in a different country. The availability zones we talk about are akin to a kind of a separate data center concept, meaning that it's very easy for you to get high availability if you need that as part of what you're doing. We're continuing to add more and more infrastructure as we go on. So convenient infrastructure for you to use, and you can use the same tool, consistent tool set, wherever is the right place for you to deploy these resources. From a capability point of view, the global infrastructure is obviously the kind of foundation layer that's very important. You choose where to put your infrastructure. With sophisticated networking on top, and we'll talk about how you can use that to create a secure connection from your current environment into the AWS cloud. And then various components that will meet the needs of the applications and the dev and test workloads you have, whether that's compute, storage, database workloads, application services, and we'll talk about some of the deployment and administration services that are most useful for these workloads in a few moments. So outside the scope of this webinar to go into every service, so we're going to just be focusing on those key services that we think can make a difference in the workloads that we've talked about. And then also to emphasize, we're very focused on saying to you to leave the undifferentiated heavy lifting to us. Now, you might not be directly responsible for building data centers in the roles that you're in now, but when we talked about the ease with which you get hardware, we look after the data centers, the power, the cooling, the cabling, the networking, racks, all the undifferentiated heavy lifting that probably isn't going to be the thing that makes a difference to your business. That's the stuff that you can leave to us. So you don't have to worry about buying and installing new hardware or configuring software if you don't want to do it. You don't need to worry about data center space. That's all the stuff that you can leave to us. All you need to think about, if you need 1 server, you need 10 servers, you need 1,000 servers, you need to set up a new environment, you choose what you want, you choose where you want it, and we will make it happen for you without you having to worry about some of the more complex, time-consuming procurement processes that you might have had to do in the past. So now we're going to look at some of the relevant services for the development and test workloads that we have. And we're going to start off talking about some of the compute services at the core. So Amazon EC2, the Elastic Compute Cloud, that's all about, at the most simplest form, virtual servers in the cloud. So you get a choice of a variety of different operating systems, a variety of different sizes of servers, and then you can use them with full administrative control as you would on-prem. Autoscaling and elastic load balancing are out of scope of what we're going to talk about today, but I want to mention them very briefly. Autoscaling in production environments is a way to make sure that you can keep up from a capacity point of view with the load that's coming in from your customers, so you can have more and more servers added to your infrastructure to take advantage to be able to deliver for the customers that are coming in to use your application. And elastic load balancing is our managed load balancing service that makes it simple to distribute traffic across the various compute instances that you might have deployed. So a few things to say about EC2. So these are resizable virtual servers in the cloud, and you can launch as many or as few as you need. You could start off with one. If you needed 2,000 for a particular project, you can do that, and we'll show you in the demonstration a bit later on. It's as easy to launch 10 as it is to launch one. There's a range of different instance sizes, and these all provide varying amounts of CPU, of RAM, of disk, and so on. And they range from very economical micro instances for very, very small low throughput workloads to very, very high performance cluster compute instances that could be used for HPC scenarios and so on, with a number in between. Very easy for you to start off with a small instance type, to prototype whether it's the right thing for your environment, and then if you need to move to a bigger instance type later on, very, very easy for you to do that. You just need to modify an attribute of the instance, and you can do that. When you have those instances launched, you have complete administrative control, root access in Linux or the administrator privileges in Windows, and a choice of Windows or Linux operating systems, a variety of different distributions to meet what you have. We also have a variety of different purchase options to support different needs. We have the free tier for new customers, which is easy to kind of get started and evaluate AWS and see how you like the service. But then when you're using it in an environment like development and test, we have some other options to purchase which are a little bit different. On demand is the simplest, and this is something with no commitment. You pay by the hour, and you pay only for what you use. Exactly the examples that we were talking about earlier. You need to have 100 instances. While they're running, you pay for them. When you stop, you also stop paying for them. Reserved instances, these are where, in return for making a low one-time upfront payment, you can receive a significant discount on an hourly charge. And that might be economically the right thing for you to do for a baseline workload or for infrastructure that you know is going to be around for a more significant period of time, rather than the kind of experimental kind of workloads where maybe it's going to be used for an hour, maybe it's going to be used for a week, a month, and so on. Reserved instances give you the choice. When you know something's going to be around for a little bit longer, you can change the way that you purchase it. Spot is a different model where you basically name the price that you want to pay for computing for unused capacity. So this price is going to be lower than what you would pay for on demand. You would set your bid, and basically as long as your bid price is met, you will get this resource at the price that you name. And that might be something that's ideal for test scenarios. You can easily and cheaply add more resource at a lower price than you would necessarily pay. And then for customers who have particular needs to have single tenancy, we also have dedicated instances, which inside the Amazon Virtual Private Cloud, that we'll mention a little bit later on in this presentation, lets you run instances that are dedicated to a single customer. So if you had particular compliance requirements or highly sensitive workloads, you'd have the ability to have those dedicated instances as well. The next services we're going to talk about are in the networking arena. There are three. We're going to talk in a little bit of detail about Amazon Virtual Private Cloud. The other two services I want to make sure that you're aware of. Amazon Virtual Private Cloud, it's basically your ability to provision a private, logically isolated part of the AWS cloud with your own networking IP address range and so on. AWS Direct Connect enables you to have private connectivity between the AWS cloud and your data center if that's something that you require. And then Amazon Route 53 is our highly available domain name service. What we're going to focus on right now is Amazon Virtual Private Cloud. And this lets you define a logically isolated network in the AWS cloud that you control. So this means you can continue to use the IP address range that you choose that fits into your existing on-premises network environment. You could create multiple IP subnets and multiple different routes. You could protect your resources with access control, whether that's security groups, which are akin to firewalls, or network access control lists. And then you can also very easily connect securely via a hardware VPN. And this makes it very easy to think of the AWS cloud as a seamless extension to your existing network. So you can connect up with a hardware VPN. IP addressing is consistent, so you could have a development or a test environment that's sitting in the AWS cloud that looks like it's just an extension of your network, and it's giving you all the elastic benefits, all the pay-as-you-go benefits of the AWS cloud. And to look at this visually, here in your production on-premises environment, you might continue to have your source control, your requirements management, project management software, shared service, build machines, and so on. Then using that hardware VPN connection, which is optional, it's not required. You can still use the AWS cloud and VPC without having to do that. Inside the AWS cloud, you might have a shared development environment. You might have some build infrastructure there if you choose to do that. But for the basic scenarios we're talking about here, you might have multiple different test environments, and you can seamlessly connect to them using a consistent IP address range that's the same as what you're already using. You don't have to reconfigure your environment to use a totally different IP address range and so on. Very, very simple for you to do this and for this to appear just like it's an extension of your regular network. Storage is a pretty important thing for dev and test workloads, whether this is kind of keeping images of the test environments and so on that you've got. So we want to overview some of the storage services that we have, and we're not going to go into the same level of detail for them. Amazon Elastic Block Store. This is basically block storage. Think of it like a disk drive for use with Amazon EC2. So you can provision these persistent volumes that can be attached to any EC2 instance that you like. You detach from one instance and attach to another. This means when these instances are not running, you still have these disks available if you need them to do that. But they can conceptually be thought of just like a disk drive. They're raw block storage. You format them with the same file system that you use in your Linux or Windows operating system as you would before. You don't have to change what you do. Some other storage options we have. Amazon S3, the simple storage service. This is our object store where you could put things that are associated with the work that you're doing. Amazon Glacier, which is for long-term archival class storage. And then the storage gateway, a virtual appliance that you can put on-premise, and then that seamlessly can transfer data to the cloud. So very seamless option there. From a deployment and administration point of view, and here we're going to go into some more detail on these services as we go a little bit more deeply. Amazon CloudWatch is our built-in monitoring service. IAM, Identity and Access Management, gives you granular control of users, groups, and permissions. So again, in a development and test environment, it's not just that one account has full control to do everything. You can set up different groups, you can set up different users, so those people only have permission to do things with the certain objects and certain resources that they require. OpsWorks is a DevOps type of framework for application lifecycle management. I'm not going to talk about that in this presentation. The two services that we'll talk about in a little bit more detail are, first of all, AWS CloudFormation. And this basically gives you a kind of a template type of approach to deploy and manage your infrastructure, which makes it very, very simple to potentially spin up multiple test environments or multiple dev environments. And we'll show you exactly how that works in a demonstration. And Elastic Beanstalk, which makes it very easy to automate resource management, very easy to take a container, to take an application that the developer might want to spin up an environment, upload that application into Elastic Beanstalk, and have all the underlying infrastructure put in there. So to give some more detail on CloudFormation, if you have a development or test stack, you define what is in that stack, and that might be a collection of server instances, it might be a virtual private cloud, security groups akin to firewalls. It's kind of, you could think of it as the kind of the list of things that you want to appear in your stack. So you define those things in a JSON template, very, very well documented, and then you basically provide that template to the CloudFormation service, and you could do that with a management console, you could do that with an API, and then you end up with a created stack. And all of the kind of the coordination of building those resources in the right order is taken care of by the CloudFormation service. You basically tell it what you want in a template. The service builds it, and you get a stack. And if you wanted to create a development stack, a test stack, an integration stack, as many as you want, you can use the same template. You give it a different name. Those stacks are created. If you wanted to create one stack in one region, in the EU, for example, you wanted to create another one in the US or in Australia or any other location that's relevant for you, you can use the same template, provide it to the service, and end up with that stack created, ready for you, your developers and testers to use and so on. So we'll show you with a very simple stack how that works in the demonstration a little bit later on. Elastic Beanstalk, you can think of this as a kind of a container-based thing. You simply, or your developers simply choose to upload your application to Elastic Beanstalk, and then Beanstalk provisions all the required infrastructure. So if you think about this in terms of a developer, they have an application, they just want to spend a few hours doing some very, very early smoke testing of seeing how this might work in a real deployed environment. They don't need to go and worry about provisioning all the different components of that infrastructure. They just take their application, and they can do this directly from an IDE they're using, like Visual Studio or Eclipse. They take that application, they put it into Elastic Beanstalk. Elastic Beanstalk goes and provisions the servers, the load balancers, any other pieces of infrastructure that might be required, still provides full control of all those underlying resources, and lets in minutes that developer go from having an application. They don't need to go and work with anybody else to get this infrastructure provisioned for the quick test that they want to do. They just load the application and they're ready to go. So very, very simple service that's useful and something that could be used in production as well, or it could just be used in the dev and test sample environment for someone to very, very quickly get an application running. And again, when you finish with the application, you turn it off in Beanstalk and you stop paying for those resources. So with all the things that we're talking about today, and in the development and test space, one of the most important things is this doesn't mean that you have to change what you're doing. This doesn't mean that you have to learn a new set of languages and so on. Very much about continuing to use the things that you are already using. So from a tool point of view, we have a number of different SDKs for the languages that developers might already be using. And that's both something that's useful for managing, making it easy to manage AWS resources that are there, or if it was in the concept of developing a mobile application, providing direct access to some AWS services in those applications. And then also integrating directly into the IDE environments to manage AWS resources, to spin stuff up and so on for environments like Microsoft Visual Studio and Eclipse. So from the point of view of a developer, doing these things, and I gave the example in the previous slide with Beanstalk, doing these things from the environment they're already using, from the environment they're already working in day to day, they can take advantage of some of these capabilities. In terms of software that you're potentially already using, again, continue to use what you're already using. This is just a sample of some of the independent software vendors and other software companies that we use. So if you're used to working in a Microsoft environment with Microsoft Windows, you can launch instances that are running Microsoft Windows. You can use the .NET SDK that we provide. You can use the Visual Studio IDE with our tools. So the message here is very much this doesn't mean that you have to change the stuff that you're doing. If you're used to using Red Hat Linux, continue to use Red Hat Linux. The same with SUSE and so on. So this isn't about you having to change. This is about us working with partners to make sure that you continue to have the choice. You continue to be able to work with the vendors, the software that you're already using. And then as you start to think about deploying or working through some of these development and test scenarios on AWS, if you do need assistance, we've got a bunch of different partners who are ready and happy to help, some of which I'm sure that you're already working with now. So whether it's continuing to use the same partner, continuing to use the same software, very, very straightforward for you to do all that stuff without having to do a lot of investment in changing things. So the next, as we get towards the end of the webinar, the next thing that we want to show is a couple of different demonstrations to show how easy some of this stuff is and make real some of the things that we've talked about. So we've pre-recorded these demonstrations just so it's easy and we don't have to make you sit through every single click. So there's a couple of sequences in the demos that are kind of, here's one I prepared earlier style. The first demonstration we're going to do is just showing how easy it is to provision resources, and the second one is going to show how we can use CloudFormation to build a more complicated stack. So we're going to start off with the first one, and this is about provisioning servers. So we're going to start off at the main AWS website, and then we're going to sign in to the AWS Management Console. Here, once we've signed into the console, this is the kind of the main page in the console for anybody who's not used it, and it shows a view of all the various services that we've got, which include EC2, VPC, and the other services that we've talked about. The focus of this demonstration is going to be EC2, and we're going to go into the EC2 part of the console and show how easy it is to provision a couple of different machines. So here's the kind of the main dashboard in EC2. I don't have running infrastructure at the moment. This is just something that we're going to spin up for the purposes of showing how straightforward it is to get resources. And the first button we're going to click is the one to launch instances. And then we have a few different options in the wizard. The classic wizard, we could go to the AWS Marketplace, which has a whole set of pre-built machines. We're going to go with the regular wizard. And here you see a range of pre-configured template machines that we could launch. There are those that are running Amazon Linux. We can see some Red Hat stuff there. And we'll look just to show you in the list, there's a whole set of different options, including different versions of Linux. As we go down to the bottom, we can also see that there are Windows instances ready to go as well. So you could choose from any of these, Windows, the version of Linux you prefer. And for this demonstration, we're going to go with a straightforward Amazon Linux. So here we have a couple of choices, the number of instances that we want to launch and also the instance type. And this shows you the range that we talked about before, from those micro instances all the way up to the high performance instances. And just giving you a quick reference here showing the CPU and RAM that these different instances have. And for the purpose of this demonstration, we're going to pick a small instance. Now, we could launch one instance, but I want to show you here that it's as straightforward, in this case, to launch 10 as it would be to launch 1. We're going to go to the next section here, and here we're given some extra options that we could configure. We could pass some initiation data through to the instance if we wanted to help with bootstrapping. We can configure some other things like IAM roles and so on. We're going to set the defaults. The other thing here is we could also do this through the API, through a command line script. I'm just showing you how to do it with the console for ease. We can configure the storage. We don't want to make any changes to the storage, so we're going to go with the defaults for storage. We could add a tag here to make it easier for management or billing. Again, we're going to go through with the defaults. We need to give it a key that we're going to use to SSH into the instance later. So we're going to make that initial connection secure. Ask us a security group to use. A security group is akin here to a firewall, so I have a pre-prepared security group, or I could create one here that's going to let everybody SSH into the instance. We can review all the information to make sure we're happy with what we're going to launch before we do it. And then we're going to launch those instances. And the console tells me some things that I can do while those instances are running. While those instances are launching. And there I can see those 10 instances. It shows me the state they're pending. And we're going to cut in a minute here just to show a little time lapse to those instances being ready for us to connect to, so we don't waste your time on the webinar. Those instances are now all running, and we could pick one of them. They're all the same. They've all come from the same template. Bunch of things we can do with them. We could connect to them. We could look at console output. We could stop them. We're going to try and connect to one of these instances. A couple of ways to connect. We could do it with a terminal that's embedded into the browser, or I want to show you here how we can do this with a standalone SSH client. And the console gives us a predefined string SSH command line that we can take, so we'll copy that, go into the terminal window, use that command line, and we'll connect up to that instance. And there, we're connected to the instance, and at this point we have full root access, and we can basically configure that however we would. I could start applying updates, say, yes, we're going to download those updates, and that will just go off as it would. I'm not going to watch it, but you get the idea there. Have root access, and it's the same as you would do in a regular, any kind of regular server. When we're done with those instances, so they've been running, maybe they've been running for an hour, maybe they've been running for a day, we're finished with them for the project, so we decide to terminate them. Say that we want to terminate them, and that's gone. They're gone. So in a very short period of time there, we provisioned 10 instances. It could have been 1,000, it could have been a lot more, it could have been one. We did it off a standard template that we have that's in the AWS console ready to go. That could be your own template that you configured with your own development and test tools ready for your environment. Very, very straightforward for us to do. We spun them up. Didn't need to do anything to reserve them. We didn't need to provision that capacity in advance. We didn't need to make a commitment. We ran them for when we needed, and then we stopped, we terminated them, and they were gone. So that was that was going back right to the start of this presentation. That was just showing how, in a very, very short space of time, we instantly procured 10 of those instances. We chose small ones. It could have been bigger ones. Whatever would be the right thing for your environment. So very easy to solve that challenge of getting easy and quick access to compute resources. The next demonstration I want to show is going to be showing how we can use CloudFormation, and that was thinking about managing those stacks of infrastructure because, it's going to be a little bit more complex than just having one instance. So we're going to move now to showing that demonstration. So we're back in the console, showing all the services, and this time the service that we're going to be picking is CloudFormation. And CloudFormation, if you remember, gives us a chance to take a script and then have that script build our stack. So here's a sample script. This is a pretty simple one. It launches one with a VPC, a virtual private cloud, and an EC2 instance. I can show you a bunch of stuff that's in the script there. We're not going to go into the exact syntax and format of the script. There's a lot of documentation on that. Here's some examples for stuff related to the subnet ranges and so on in that virtual private cloud. So I've stored that script in Amazon S3. So I'm going to copy the URL for that script. I could do this by uploading it if I wanted to. Then we're going to go back into the management console. I'm going to go into the CloudFormation part of the console, say that I want to create a stack. Simple. I give it the name of a stack, so this could be my sample development stack. I could choose a sample template, but in this case I'm going to use the template that I've chosen for this demonstration. So I put in the URL. And then based on what's in the script, the console gives me some prompts. So my particular script lets people choose the IP address range for people to be SSH in. I could choose the instance type, and I need to give it a key. You define what these prompts are by how you write the script. This is a very simple one. This could be much more complex for stuff that you can pass in. I could use tags here for management and so on. I don't need to do that. I'm going to go through with the defaults. Here we'll have the options that we chose confirmed. Choose the stack's going to happen, and that stack is in the process of being built now. So a whole bunch of different things that are going to get built. Whilst that is in progress, I can look at this tab lower down called Events, and it will also show me exactly in order what's happening, where it's up to. And if I click the refresh button here, I will see exactly where things have got up to. So, for example, VPC has started being created. So we're going to fast forward now to that script, to that stack being complete. We look in the events history that we have there. So we have all these things that it did right from the start of the stack to building the VPC to launching an instance and so on. So it gives you information that you can look at as those resources are being created. And then those resources are available to you. You have full control over all of those different resources. So if I go back into the EC2 part of the console, we terminated all the instances before that we'd used for the simple part of the demonstration. And if I go into the EC2 part of the console, I will see that I have one running instance, which is the one that the CloudFormation stack created for me. I'll see all the other terminated ones that we had before. So there we see we have one running instance. It's based on that stack. If we go into the VPC part of the console, the virtual private cloud, if you remember, we'll also see that we have a VPC created, and that VPC was created by the CloudFormation stack. If we had other things that were in that script, they would also be created. We'd still maintain full control over them. They would appear in the console. So what CloudFormation is letting you do here, you could have gone and created all this stuff manually, but CloudFormation lets you take that template, put the things in the template that you want, have the kind of custom prompts you want to have them created. Now, we could modify that stack if we wanted, we could delete it, we could update it, or the other thing, on the multiple stack concept we talked about before, we could create another one. So this could be my test stack, or it could be one I'm using for a special project. Again, I'm going to take the same template URL, and I'm going to continue, and I'm going to take the default options. I need to put in that key, again, that I would use to SSH into the instance. Click continue. Don't need to give it a tag at this point. Again, get a chance to review those options. And again, this could also be done with a command line tool, with the API. I'm showing you how to do it through the console because it's more straightforward. And there, that other stack is being built now. And if that stack was more complicated, if it had multiple different servers in, you could create one. In this case, we're going to delete the first stack, which is warning us that those resources are going to go away. Yep. So now in reverse, we've got one stack that's being built at the moment. We've got another one that's being deleted, and we see that same thing in that event section, that if we refresh that, we'll see those various different pieces of the infrastructure being deprovisioned in a coordinated manner. You don't have to worry about those steps. So that's the end of that bit of the demonstration. We did it through the console. We did a relatively simple thing. We had a template that said, hey, I want an EC2 instance, I want a VPC, I want these other simple things. If you have a complex multi-tier application, you could have templates that could build a complex environment for you that maybe have 10 different servers in, maybe have 100 different servers in. CloudFormation will build that for you. It will do it in the right order. It will make sure there are no issues with dependencies and so on. And if you want to, you want to take that template and you want to go and build that stack in a different country, you want to go and do it in Japan, you want to go and do it in Australia, you can do that very easily. You have another project on a Monday morning, and you quickly need to build up another test environment to try and experiment, to try and see in response to some external factor whether you can do something. With CloudFormation, you can spin it up. You can spin it up for a day. You can do the work that you need to do. When you're finished, you click Delete Stack. All of that infrastructure goes away. You don't have to pay any more for the stuff that you've turned off. You've only paid potentially for using that for 4 hours to quickly do what you wanted to do. Very, very difficult to do that in the on-premises world where you just can't, it's very unlikely you'll be able to provision that kind of infrastructure with that kind of speed. So that's the kind of the end of the webinar at this point. This was intended to give you an overview of some of the challenges we hear from customers and how we think AWS can address some of those. If those scenarios are interesting for you, then we'd encourage you to sign up for an AWS account if you don't already have one at aws.amazon.com. You can experiment without paying anything. We have a free tier, and the documentation will tell you exactly what that gives you in resources, but you can kind of get your feet wet and experiment with no charge at all. Please read the solution brief that goes along with this webinar that provides some more information on those services. And if you think this is interesting to you and you'd like to know more, then contact us, and you can do this on the page on the AWS website for Dev and Test. You can contact us for a consultation with a cloud expert at the URL that's at the bottom of this slide. Talk to your partners in IT. We're ready to help them out if they need help connecting to AWS and so on. And then the other thing is start experimenting with AWS. There is no commitment. You sign up for an account. You can do all of the things that we've shown you in this demo very, very easily. And that concludes our webinar. So thank you very much for your time. I hope it's been a useful overview if you're new to using AWS, and I hope that AWS will be useful for you to solve some of the challenges you may be experiencing with on-premises environments. And at this point, we'll be happy to take questions if anybody has them.
Thanks so much, Paul. So we do have some questions in there. If you want to go ahead and take a look and walk through some of those questions. While you do that, I just want to remind everybody we do have a survey for today's event. If you could go ahead and fill that out, just let us know what you thought. We do appreciate your feedback. And I did post in the Q&A window over there, I posted the link to our SlideShare channel and also to our YouTube channel. So you can go up there to get our on-demand recording of this webcast on the YouTube, and then also the PDF of the deck on the SlideShare. And Paul, are there any questions there you want to go over?
Yes. So the first question we had was, can I set up test WordPress sites on AWS? And the answer to that question is yes. One of the other questions was, can the AWS environment be used for development such as dynamic navision? I assume this is a Microsoft thing with specific modules from a third party. And the answer to those questions is generally, the answer is yes. There may be licensing restrictions from some partners. I mean, Microsoft is a very major partner for AWS, and a lot of Microsoft software people use. From a technical point of view, the answer is generally yes. I mean, software that you're currently using today, with very, very few edge cases, you can continue. You can use that for dev and test environments in AWS. There was a question about database maintenance and indexing and whether that's included. What I would say here is, when you're spinning up EC2 instances, you can basically run whatever database software, MySQL, Oracle, Microsoft SQL Server on those instances, and you have full control over what you're doing there. We also have managed database services. So one of our services is called the Relational Database Service that gives you a managed version of MySQL, of Microsoft SQL Server or Oracle. We didn't talk about them in this webinar because they were outside of the scope. I would encourage you, if you want to know about the managed database services we offer, go to aws.amazon.com/RDS and you can read about that. But if you're running your own database in EC2, you basically have full control there. So we let you, if you choose not to patch your database, you don't want to maintain it, that's your choice. If you want to maintain it, that's it. With RDS, we do a bunch of the maintenance for you. It's down to how much choice and how much control that you want. Do templates provide an out-of-the-box configuration? So there's a question about templates, whether they provide an out-of-the-box configuration or can you save your own configurations back into a template? I'm not sure I totally understand the question, so I'll try and answer it. That if you took an EC2 instance like the one that we launched and it was Linux, and you take the raw instance and you add your own development tools or you add the configurations for your environment, then yes, you can create an image of that, and we call that image an AMI, an Amazon Machine Image. So if you took an Amazon Linux or a Red Hat Linux image and you install a bunch of software that was custom for you, yes, you can then make that into a template. So the next time you launch that instance, by the time it starts, it's got your stuff on it. Now, there are multiple different approaches you could take to that. You could use something like Puppet or Chef to favor a more dynamic configuration, but the simple answer is yes. If you have an EC2 instance that's customized and you want to create an image, yes, you can do that. How do you create a CloudFormation template? Bunch of different ways to do that. There's an offering called CloudFormer we have that helps create a template from infrastructure that you have that's already running. We also have a bunch of sample templates that you can use. You can do it using integrated into the IDE that you're using. So a number of different ways to create CloudFormation templates. Oh, good. I've just been told I've answered the templates question. Good. Glad that I answered that. Someone said, can you explain how the calculator is working so I can calculate easily how much it will cost you for a month? We have something called the Simple Monthly Calculator that's on the AWS website, and in that you can plug in what you think you're going to use, and it will give you an idea of what your monthly bill will be. But also do remember, we can set up things like billing alerts in AWS, so you can set a threshold with CloudWatch so that your bill, if it looks like your bill's going to go over a certain amount, you can be alerted. So if you're worried about that, you don't have to commit to what a monthly bill is. There's no kind of minimum threshold you have to get to there. The Simple Monthly Calculator can help you. You can set up billing alerts to make sure your bill doesn't go over a certain amount without you being notified, and so on. And then the next question we have, how do we go about setting up scaling for a test environment? Do we recommend a particular third party like RightScale, for example? So from a scaling point of view, this really just depends on what you need. So within Amazon EC2, for example, if you start, you can either say, I want 5 instances in my environment, and that's it. And there will always be 5 instances until I terminate them or until I add instances. We have something also called auto-scaling that's built in. And auto-scaling basically lets you say, based on a metric like CPU utilization or network traffic, for example, could say, if these thresholds are reached, we should add more instances or we should take instances away. So, if you wanted to have a kind of a dynamic test environment, as load goes up, more instances can be added to that environment up until a limit that you specify. And the reason for doing that could be based on CPU, it could be based on network utilization, it could be on a custom metric for you, and you also define the upper limit. So you're not going to end up with 1,000 instances unless you really want to have 1,000 instances. So that's built into the AWS platform, and then we also have partners, and RightScale as a partner, the customer who asked that question mentioned. And if those partners provide things that are useful for you, then absolutely you can use them as well. But autoscaling is kind of based in there. Can you clone a running instance to use it as a sandbox was another question. And yes, effectively you can do that. I mean, if you had a running instance that was ready and you got that for a particular test environment or a particular dev thing that you were doing, yes, you can basically say, I want to make an image of that machine. You get an Amazon machine image, and then from that template, you could spin up 20 sandboxes. You could spin up one sandbox. You could spin up two. But that's exactly one of the things that this makes it very easy to do, that you can go and set up a lot of different sandbox environments. And again, you could run them for an hour. You could run them for a day, and so on. Does patching of application servers happen automatically, or do you get the opportunity to specify a version, and so on? So here, when you run an EC2 instance, and this is kind of goes back to the point that you continue to do what you've always done. When you launch an EC2 instance, whether it's a Microsoft Windows instance or it's a Linux instance, you have full control over that instance. So if you don't want to patch it with security patches, or you don't want to patch it with, say a SQL Server patch or so on, it won't be patched. We give you full control. We don't want to make decisions for you. So if you're testing, and if the particular version of SQL Server or the particular version of MySQL that you use in your environment is version X, you have full control over whether you want to upgrade that or not. We don't make decisions for you in that kind of thing. The whole concept there of infrastructure as a service is you have full control. You want to patch, you want to change what's going on with the kernel, you want to change the configuration. That is totally up to you. So you don't have unexpected stuff that's going on. But also makes it easier for you. If you wondered, it's like, I kind of want to try this release of MySQL, but in your current world, it's like you don't have a spare environment to do the regression testing. With AWS, you could spin up another stack. You could put the version of MySQL on that you want to test with. You could run your regression test, depending on how long that's going to take, and maybe you get an answer to that question in an hour instead of having to wait a long time until you had access to do that. Is there any tool to design my cloud in terms of number of instances depending on the expected traffic and service? Yeah, I mean we've got a bunch of resources on the website that can help design what you're going to kind of do. Again, I would go back to some of the infrastructure as a service stuff. This is very similar. We're not saying this is a changed world from how you think about having an instance running MySQL, for example. We provide information on the capabilities, CPU, RAM, etc. for instances. So one thing that makes it very simple for you is if you were going to, in a test environment, you wanted to run MySQL, you could start it off in a smaller instance. If you found that you need something at higher capacity, you could modify the attribute to make that a bigger instance. If you found actually you started with a bigger one and you wanted to go to a smaller one, it would be very straightforward to do that as well. So the question saying, this presentation concentrated on development test services. Are the considerations for using AWS for production? Kind of an interesting question to answer. Yes, this presentation was all saying it's really easy for you to go and do dev test stuff, but a lot of the things that you would learn, a lot of the principles you would take are exactly the same if you were going to run this in production. One of the things we recognize is it's much easier for you to start experimenting with dev and test environments very easily, but all the things we talked about, these services, all these tools, EC2, CloudFormation, and so on, these are all used by customers in production environments as well. There is a question about enforcing patches and upgrades. Would we enforce patches and upgrades if a serious security risk was identified? Here, we have a white paper on security that you can find at aws.amazon.com/security. one of the things that we have that's very important to AWS is something we call the shared responsibility model, where our customers are responsible for what they do with the instances. And if you're running a Windows instance or a Linux instance, and this is a very important thing, we don't have access to that. We don't know what you're doing. We don't have any of the credentials for getting access to your instances. So if you're not going to patch stuff, if you decide that you're not going to patch stuff, we can't enforce. When we don't have access into your instances. We don't know whether you're running MySQL, for example, and what version you are. We give you the full control to choose what you do from a patching point of view. Now, one of our services, for example, the relational database service, that is a managed relational database service where we do the management of the database service for you. So we take care of things like patching. If you're running an EC2 instance and you're deciding the database software that you want, you have full control over that infrastructure. So we don't know whether you're patching it or not. We would obviously probably suggest to customers as a best practice that they patch, but we don't have visibility inside those instances. There's one question here. A customer said they can see the appropriateness in terms of unit testing, but is it appropriate for end-to-end testing where one application is deployed on AWS while the remainder remains on-premise? And I think the way we would think about it here, if you think of something like the Amazon Virtual Private Cloud with a VPN connection, given that you can choose the IP address ranges you use, you basically start to think then of AWS being an extension of your corporate network and your data center. So then, yes, you could basically say you happen to have some Linux or some Windows instances that are deployed in AWS, but you can ping them. They have IP network connectivity that is no different than they were at a different regional office or a different data center in your environment. So in that sense, if you decided in your environment that you just needed 10 extra Linux instances to do some of the test work for your environment, the fact that they're deployed in AWS is good because it was very easy for you to deploy them. But it doesn't make, the fact that they're in the cloud doesn't mean they can't take part in that kind of, system test infrastructure. No, not at all. So it's entirely appropriate. You could go, it's good because you could go off and do something totally isolated and take a test environment and spin it up in a few minutes and try that stuff that you've been wanting to try for a few months. That's very easy. But if you wanted to integrate that into stuff on-prem, you can do that very, very easily as well. Just looking to see whether there are any questions before we run out of. How easy is it to move applications from one hypervisor to another or to scale up and out with AWS? So we have services that are relevant there. There's one called VM import export, which make if you have a VM that's ready that you're using in your existing environment, you can take that VM and you can import it into Amazon EC2 and use that right away. You could build the infrastructure yourself. So it's straightforward to move in there. And then in terms of scaling out and scaling up, very, very straightforward. I mean, the auto-scaling service we didn't talk about in this presentation, but that kind of scaling, something that's very, very simple to use, and large customers, Netflix is a customer that's often referenced for this, where you can use those services to seamlessly, automatically scale out as you need to increase capacity or reduce capacity dynamically. You can scale up because you could start with a small instance, and if you want to go up to a much larger instance, it's just a matter of modifying an attribute there that you can do at your convenience. So easy to do that kind of scale up. You can deploy a virtual networking and security appliance instead of a hardware VPN. So yeah, when we talked about the hardware VPN before, what that was trying to say is it's very simple, and inside the VPC console, if you want to connect, and you've got a Cisco or Juniper or another hardware VPN device on your premises, you can configure that in the console, and we'll provide you a downloadable configuration, and we'll provision it automatically for you, so you can have a VPN. If your network guys are helping you, you can have your network connection set up very, very quickly. But if you wanted to use a software VPN, you wanted to configure that on Microsoft Windows, or you wanted to configure that on Linux, yes, you could deploy a software appliance doing that and set up the VPN yourself. The hardware VPN option just makes it easy because then the termination in the AWS cloud, we manage that. We manage the redundancy of the hardware. We take care of that infrastructure. Again, taking that heavy lifting. If you want to choose to manage a VPN, a software VPN appliance, you are more than welcome to do that. But if you'd rather leave that work to us and focus on your dev and test environments, you're welcome to do that as well. We give you the full range of choice. It looks like we are out of questions and just getting to time now, so I am going to stop answering questions and hand back to Aurora. If you have further questions, please, like I said on the call to action page, contact us so we can follow up with a consultation to see how this could be useful for you.
Wonderful. Thanks so much, Paul. So just a reminder before I close this out today, if you could go ahead and take a moment to fill out our survey. We do appreciate all your feedback. And with that, I would just like to say a final thank you, and thank you to Paul for presenting today for a great presentation. And thank you, everyone, for joining us. That concludes our presentation today.